An unsettling discovery about this massive celestial body, renowned astrophysicist Brian Cox has issued a grave warning leading to the looming question. Are we about to witness a catastrophic supernova explosion that could permanently alter the night sky? Let's delve into this phenomenon in the vast tapestry of the cosmos, where stars are born, live out their lives, and eventually die in spectacular displays. One star has recently captured the attention and concern of astronomers and the public alike. This star is Betelgeuse, a red supergiant of immense size and age, prominently located in the constellation Orion. Its distinct reddish hue and variable brightness have long fascinated observers, but recent developments have intensified interest in this celestial giant. As we explore Betelgeuse's nature, we find ourselves on the brink of a potentially monumental event in its life cycle. But what do these changes in Betelgeuse indicate? Could we be witnessing the prelude to a cosmic spectacle of unimaginable magnitude? Betelgeuse, approximately 764 times larger than our Sun, is a stellar giant. Its colossal size is almost beyond human comprehension. Imagine a star so vast that if it were to replace our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This immense size is not just a testament to Betelgeuse's physical attributes, but also signifies its stage in the stellar life cycle as a red supergiant. Betelgeuse is in the twilight of its existence, a phase characterized by expansion and cooling after a life spent fusing hydrogen into helium in its core. But how old is Betelgeuse? This star, believed to be around 8 to 85 million years old, is relatively young in human terms but ancient in the context of stellar lifetimes. Its current red supergiant phase is the culmination of millions of years of stellar evolution, marked by dramatic changes and processes that have transformed it from a hot blue star to the red giant we see today. The life cycle of stars like Betelgeuse is a tale of transformation driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's distinctive hue is another hallmark of its current stage. The red color results from its relatively cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,500 Kelvin, allowing it to emit light at wavelengths that give it a red appearance. But this color is not just a visual trait. It provides insights into the star's physical condition and the processes occurring within its vast gaseous expanse. Adding to Betelgeuse's mystique is its historical color change. Ancient Roman and Chinese records suggest that around 2,000 years ago, Betelgeuse appeared yellow. It was only in the 9th century that Arabic scholars first described it as red. This color shift over human history is not just a detail in the annals of astronomy but also a clue to the star's evolutionary path. The variable brightness of Betelgeuse is another intriguing aspect. It is a semi-variable star, meaning its light periodically waxes and wanes, a characteristic dance of luminosity that has fascinated astronomers and skywatchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle, along with a longer cycle that stretches about 5 years. These cycles have been documented as far back as the 36th century by Sir John Herschel and possibly even earlier in Aboriginal oral traditions. What makes Betelgeuse truly enigmatic is not just its changing brightness but also its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes occurring within its colossal form. In a recent groundbreaking revelation, Betelgeuse captured the attention of astronomers and stargazers worldwide with an unexpected and dramatic change in its appearance, now famously known as the Great Dimming. In late 2019, Betelgeuse, the red supergiant and one of the brightest stars in the night sky, located prominently in the Orion constellation, began to dim mysteriously. This dimming was so notable that it started losing its brightness at an average rate of 0.1 magnitudes per day, reaching its lowest point in February 2020. Betelgeuse, typically visible to the naked eye even in areas with light pollution, became noticeably fainter, a change that amateur observers could easily spot. However, monitoring Betelgeuse's activities poses a challenge due to the time paradox. When we observe a star like Betelgeuse, we are seeing it not as it exists in the present, but as it was in the past, because of the time it takes for light to travel to us. In the case of Betelgeuse, which is approximately 725 light-years away, the light we see today left the star nearly 7 centuries ago. This time lag makes predicting and monitoring sudden changes in a star's behavior difficult, as we are essentially looking into its past. The dimming event of Betelgeuse highlighted the inherent difficulties in real-time astronomical observations and the limitations of our understanding when dealing with vast cosmic scales and the time paradox they introduce. This celestial drama of Betelgeuse was closely observed by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team. They used the Hubble Space Telescope to study the giant star as part of a 3-year study on variations in its outer atmosphere. These observations provided a unique insight into the dynamics of a variable star like Betelgeuse, which expands and contracts, causing fluctuations in brightness. By analyzing Hubble spectra, the researchers measured the movement of material in Betelgeuse's outer atmosphere, particularly focusing on magnesium-2 lines, which indicate the star's atmospheric conditions. These observations revealed material moving at speeds of about 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's dimming. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss was significant, especially considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate far greater than that of our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. Betelgeuse's proximity, about 725 light-years from Earth, adds to the anticipation, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. However, the question remains, what does this dimming event mean for Betelgeuse's future? Is it a sign of an impending supernova or simply a unique episode in the star's long and complex life? Several theories were proposed to explain this sudden change. One prevalent theory suggested a phase in the supernova explosion process gaining traction due to the common belief that Betelgeuse is nearing the end of its life. Another popular theory implicated dust, possibly from the star itself, obscuring our view. Betelgeuse, like other red supergiants, is known to shed material, and this material could form a dense enough dust cloud to dim the star's light from our perspective. A third explanation considered changes in the star's photosphere, the visible surface layer, which could affect its apparent brightness. In-depth analysis using various observational methods helped unravel this mystery. Spectroscopic studies indicated a drop in Betelgeuse's effective temperature, suggesting that the dimming could be due to a large dark spot on the star's surface. This theory was supported by the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, indicating significant changes on its surface. Ultimately, the key to understanding this unusual phenomenon came from Hubble Space Telescope observations, revealing that Betelgeuse's dimming was most likely caused by a significant ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, effectively reducing the amount of light reaching us from Betelgeuse. The dust cloud was thought to originate from superhot plasma, which erupted from a large convection cell on the star's surface and then moved through its hot atmosphere to the colder outer layers. As it cooled, it formed dust grains, creating a cloud that obscured light from approximately a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, starting in January 2019, were crucial in constructing the timeline leading up to Betelgeuse's darkening. These observations captured signs of dense, heated material moving through the star's atmosphere in the months before the dimming. In December 2019, several space telescopes also noted the star's diminishing brightness, particularly in its southern hemisphere. This material, initially brighter than the star's normal luminosity, eventually formed a dark cloud as it moved outward and cooled. The theory was that this outflowing material and resulting dark cloud caused the star's sudden dimming. The scale of this ejection was monumental, thrusting Betelgeuse into the astronomical spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This ejected material, believed to weigh several times as much as our moon, was significant not only for Betelgeuse but also for our understanding of stellar mechanics. But what does such a massive ejection of material imply for Betelgeuse and supernova theories in general? The implications for supernova theories are profound. The traditional understanding suggests that red supergiants like Betelgeuse shed mass at a relatively steady pace before their explosive end. However, the scale of this ejection challenges this notion, indicating a more turbulent and possibly unpredictable end-of-life phase for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion within the next few millennia? Recent studies speculate on the timing of such an event, suggesting it could be sooner than previously thought, potentially in just a few tens of years. Another critical aspect of the Betelgeuse puzzle is the concept of a bow shock. As this massive star moves through space at about 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, similar to the wave formed by the bow of a moving ship. This phenomenon occurs as the star's outer layers interact with interstellar gases and dust, providing a spectacular demonstration of the star's dynamic nature and its interaction with the cosmic environment. Studying this bow shock informs us about Betelgeuse's current state and contributes to our understanding of stellar evolution and mass loss processes. Betelgeuse's recent behavior includes observations of its surface cooling and becoming less dense following the ejection event, leaving the star in an unstable state even years later. Hydrodynamic simulations suggest a link between the star's convective activities, mass ejection, and subsequent pulsation mode switching. This ongoing instability raises questions about the internal processes driving these changes and how they might evolve in the future. Moreover, Betelgeuse's observed mass loss rate is significantly higher than many other stars, suggesting a complex interplay of internal forces. The pulsation, partly responsible for this mass loss, is limited by constant energy dissipation through shock heating and mass ejection. These observations underscore the dynamic and somewhat unpredictable nature of Betelgeuse's life cycle, challenging astronomers to reassess their models of stellar evolution. However, with all these dramatic changes, the question remains, is Betelgeuse on the verge of going supernova? While the timing of such an event remains uncertain, the recent unprecedented mass ejection has certainly shifted the conversation, hinting at a more imminent end than previously anticipated. Theories now grapple with the implications of such massive material loss and its impact on the star's stability and future. Meanwhile, as the astronomical community closely observes Betelgeuse, another cosmic event captures attention and provides a vivid comparative study: the supernova SN 2023X. This spectacular explosion occurred in the galaxy Messier 101, known as the Pinwheel Galaxy, located just 21 million light-years away. Discovered in May 2023, SN 2023X is not just another supernova. It is the nearest one observed in recent years, offering a valuable close-up view of a star's cataclysmic end. The discovery of SN 2023X was a significant astronomical achievement. Kai Toi, a well-known amateur astronomer for his discoveries of supernovae, first spotted this rapidly brightening speck on the outskirts of Messier 101 using a modest 23.5 m telescope. Upon announcing his find, the astronomical community sprang into action. Telescopes worldwide, from those on Earth's surface to the orbiting Hubble Space Telescope, turned to capture the unfolding drama of this newborn supernova. The subsequent race to monitor SN 2023X's light curve offered crucial insights into the explosion's nature and the environment around the doomed star. In the tumultuous month following its discovery, SN 2023X's behavior was meticulously recorded. The supernova surged from relative obscurity to dazzling peak brightness within just 5 days, then began a more gradual decline, dimming by 0.3 magnitudes daily. Spectral analysis revealed numerous bright emission lines, indicating the violent interaction between the expanding supernova shockwave and the surrounding gas. This was not simply a star reaching the end of its life. It was a massive star collapsing under its weight as its nuclear fuel ran out, with the outer layers rebounding off the dense core in a spectacular core collapse supernova. What makes SN 2023X particularly intriguing is the dense shell of gas enveloping it, significantly affecting the shockwave's escape from the star's center. Two scenarios could explain this dense circumstellar material. Either a strong, steady wind had been shedding material from the star before the explosion, or the star experienced sporadic outbursts ejecting material into space. In either case, it's estimated that the star lost up to a solar mass of material in the last 1 to 2 years of its life, indicating that its final moments were far from tranquil. Determining the progenitor of SN 2023X has become a major focus of study. Through various methods and datasets, researchers have converged on a likely candidate, a red supergiant. By studying the details of SN 2023X's explosion, including its progenitor's characteristics and the mechanisms leading to its final detonation, astronomers can refine their models of stellar evolution and supernova mechanics. These insights directly inform our understanding of Betelgeuse's current state and its potential path to supernova, providing a clearer picture of what signs to look for and how to interpret the massive red giant's complex behaviors. Regarding Betelgeuse's potential for a supernova, research from Japan's Tohoku University suggests that Betelgeuse might currently be in the carbon-burning stage of its life, which typically precedes a star's demise. Hiroyuki, the study's lead researcher, suggests that the star's core could collapse a few tens of years after the carbon is exhausted. Conversely, researchers from Hungary's Konkoly Observatory believe Betelgeuse is in an earlier helium-burning stage. Despite these differing views, there is a consensus that Betelgeuse is likely to be the next supernova in the Milky Way, although this event might not occur for another 100,000 years. Historically, observations of supernovae have provided invaluable insights into stellar deaths. The earliest confirmed record of a supernova, dating back to 185 AD, was observed as a bright star that took about 8 months to fade from the sky. Since then, several significant supernovae have been recorded, including SN 1006, the brightest recorded star ever to appear in our night sky, visible across various parts of the world, and SN 1054, which resulted in the formation of the Crab Nebula and was visible in daylight for 23 days. The most recent supernova observed in the Milky Way was SN 1604, studied extensively by Johannes Kepler. More recently, supernova 1987A in the Large Magellanic Cloud was observed within hours of its light reaching Earth, marking the first supernova detected through neutrino emission and observed across every band of the electromagnetic spectrum. These observations have played a crucial role in developing successful models of supernova behavior and enhancing our understanding of their impact on star formation. Imagine if the night sky suddenly lit up with the radiant explosion of a star, captivating our gaze with cosmic fireworks. Picture the once familiar constellation of Orion, adorned with an unfamiliar blazing jewel. Betelgeuse, one of its prominent stars, transformed into a brilliant supernova. Could this inspiring event have any impact on Earth? Betelgeuse's impending supernova is classified as a core collapse supernova, which occurs when massive stars exhaust their nuclear fuel and can no longer support their own gravitational collapse. These supernovae are among the most energetic and cataclysmic events in the universe. When Betelgeuse eventually goes supernova, it will release as much energy in a matter of seconds as our Sun will emit over its entire lifespan of billions of years. The energy output from a supernova primarily takes the form of electromagnetic radiation, including visible light, X-rays, and gamma rays. However, the most immediate and visible effect of a Betelgeuse supernova would be a spectacular light show in our night sky. The explosion would briefly outshine the moon and would be visible even during the day. Imagine looking up at the daytime sky and witnessing a second incredibly bright sun appear for a few weeks or even months. The event would be a breathtaking celestial display, captivating astronomers and stargazers alike. But as fascinating as the visual spectacle of a Betelgeuse supernova would be, its true significance lies in the scientific opportunities it presents. Supernovae, particularly those of massive stars like Betelgeuse, are cosmic laboratories that offer invaluable insights into the fundamental workings of the universe. One of the immediate benefits of observing a Betelgeuse supernova would be the opportunity to witness the final stages of stellar evolution up close. When massive stars like Betelgeuse explode, they distribute elements forged within their cores, including heavy elements like iron, into space. This process is responsible for enriching the universe with the building blocks of planets, stars, and life itself. By studying the spectroscopic signatures and the distribution of these elements in the aftermath of a supernova, scientists can gain a deeper understanding of how stars evolve, fuse elements, and contribute to the formation of new celestial bodies. This knowledge is crucial for unraveling the history and composition of the universe. While the visible light from a Betelgeuse supernova would be dazzling, an equally intriguing aspect of the event is the emission of neutrinos. Neutrinos are subatomic particles that are notoriously difficult to detect because they rarely interact with matter. However, in the intense environment of a supernova, they are produced in vast quantities. These elusive neutrinos offer a unique window into the heart of a dying star. They can provide information about the core collapse process, shedding light on the fundamental forces and particles at work during a supernova explosion. Detecting and analyzing these neutrinos would be a momentous scientific achievement, potentially unlocking secrets about the universe's most extreme environments. The observation of a Betelgeuse supernova could also have implications for our understanding of the universe's expansion and the enigmatic force known as dark energy. In the late 1990s, observations of distant supernovae led to the discovery that the expansion of the universe is accelerating, not slowing down as previously thought. Betelgeuse's supernova, being relatively close in cosmic terms, would provide a valuable data point for studying the expansion rate of the universe and the role of dark energy in driving it. It could help refine our understanding of these fundamental cosmological concepts, possibly revealing new mysteries about the fate and nature of the cosmos. But what could be the potential consequences of a Betelgeuse supernova on Earth? Is humanity in danger? Considering the vast distances that separate us, this is an unlikely possibility. To put the size of our universe into perspective, consider that 1 light-year is roughly 5.88 trillion miles. Betelgeuse, at 725 light-years away, is more than 4,267 trillion miles distant from our planet. This enormous separation provides a degree of cosmic insulation, and any direct physical harm to Earth from the explosion itself is extremely unlikely. However, the event would undoubtedly have significant scientific, cultural, and philosophical implications for humanity. The explosion would be a stark reminder of the dynamic and often violent nature of the universe, prompting reflections on our place within it and our understanding of cosmic phenomena. It would inspire awe and wonder, fueling scientific inquiry and exploration as we seek to unravel the mysteries of the cosmos. In conclusion, Betelgeuse, the red supergiant star in the constellation Orion, has captured the attention of astronomers and the public alike with its recent dimming and unprecedented mass ejection. While the exact cause of these events remains the subject of scientific inquiry, they have sparked discussions about the star's future and the potential for a spectacular supernova explosion. Observations and studies of Betelgeuse's behavior offer valuable insights into stellar evolution and supernova mechanics, informing our understanding of the universe's most extreme phenomena. The prospect of a Betelgeuse supernova presents both scientific opportunities and existential questions, highlighting the dynamic and ever-changing nature of the cosmos and our place within it.